Hello everyone. Today we are going to explain and demonstrate how the HUCEEN H71200 CPU connects to the HUCEEN IM155 distributed I/O. First, as we can see, the CPU has two network ports on it. One network port, we might use a network cable to connect to the M15, and the other port I have connected to my laptop. Our 155 also has two network ports below. So if we have more M15s later on, we can just daisy chain them directly from this network port without needing to use a switch. We later added a QT16 at the back, but actually, after this 15, you can add up to 16 of these smart modules. First, let's add the CPU. For the CPU, we are choosing this one. Currently, Huiching only has one model, which is the 1215 DC-DCRY. So currently it's the 3.0 firmware. Don't select the one below. That's not correct. Right now this is Huicheng's 3.0. Maybe in the next 2 years we will upgrade to a higher firmware version. Once that's confirmed, next in the network view we will add a 5. If this is your first time using it, you might not have this M15 yet. The thing is inside, I already have M15 installed here. If you do not have it, we need to install it. First, you need to get a GSD file. After you get this file, put it in a folder. For example, you can create a folder on your desktop. Put it inside. So I'll just put mine on the desktop. So how do we add it? First, down here in management, we find your folder. And then on the desktop, M15. At this point, you might not see this thing, but actually it doesn't matter. You just directly select the folder, choose the folder, and that's it. Now it has already popped up, right? Since it has popped up, let's reinstall and try again to see if it can be installed. Right now it says we've already installed it, so there's no need to install it again. If you haven't installed it before, it'll just start installing directly now. Okay, that's done. Let's close this. Alright, let's go to the network view. Look for IO down below and let's find WeCheng. Here is M15. Now let's drag it out. And after dragging it out, we need to connect M15 to the PLC on the network. We can select it like this. Alright, now it's connected. For M15, we can take a look at its network interface. Where might you need to modify the parameters here? The first is the address of your network port. For example, the network address here needs to be on the same subnet as the CPU. By default, when you create a new CPU, it's set to 192.168.0.1 and the default for a newly created device here is .2. Of course, you can also modify it further if needed. Here is the name of its Profinet, but by default it already has one. Of course, you can uncheck it if you want, for example. You can also add one yourself, that's fine too. Let's add one now and give it a good name. Remember to save it at any time, that's important. Also, there's another thing. Our distributed IO refresh time. We can adjust it a bit, maybe make it a little longer. Then, for IO cycle, the default here is 128, right? It doesn't really matter, but let's try changing it and see. Let's set it to 16. Now let's download it. Here we select view all. Now we found a CPU. Don't worry about this address for now. Then we click download. Now it can be downloaded normally, okay? But just now we forgot one thing. At the back we added a module. Since we added a module, we need to add it in the software as well. Otherwise you won't be able to see the effect. Let's take a look at this module. Open M15 and you can see here it's from 1 to 16. So we can add up to 16 modules. We've added 16 modules. Let's find our Qt16 because we've installed Qt16 on the hardware. So let's locate it. Of course, for other modules, you just need to adjust according to how you've actually installed them. Just follow that order. We'll drag it up here and finally we can check its address. This is the address of Qt16. Its address is 23, which actually represents QB. Ah, 22 and 33. Alright, now that we found the address, let's download it again. Now we'll use the software to control its output. First, we can add a watch in the monitoring table. Of course, you can also write a program. Let's write a simple program here. Program. Before everyone starts programming, we might need to use the 1 second pulse. To use the 1 second pulse, let's turn this pulse on. 0.11 Hz. Let's confirm that we are using a 1 Hz pulse to trigger the falling edge. For example, let's add an N. Alright, so for the rising edge of the 1 second pulse, we'll set 255 to QB2. This QPR is the output address for our QT16, and we are giving two of these to QB3, another one. Next, for the falling edge, we'll write 0 to turn it off. Okay? This address needs to be changed a bit, just copy it. With this, a program simply uses the second pulse to turn on the output point at the rising edge of the second pulse and turns it off at the falling edge. Now let's download the program. Alright, let's monitor it. Since we've changed this location, it needs to reconnect now. So let's wait for it to connect. Now, why does it go online every year? There might be a reason for that. Let's take a look here. There should be a setting for the device name at this place, and maybe this is different. Let's check the name. Sure enough, it's different. So, before the alarm for not being connected goes off every year, we also need to check whether the name of this M5 matches the name you set. If it doesn't match, then you still need to perform this operation to set the name for it. Alright, let's set the name now. Okay, it's set up now. So let's wait for it to connect successfully. Alright, let's check online now. Let's give it a try. It's already connected successfully. Okay. Next, let's look at the program. Here it jumps. So let's stop it first and re-download. Alright, now we can see that the program is already running here. Let's check the actual output to see if there is any. Now it's downloading again. And after connecting for a while, you can see that it's already running. Is there some problem with the program? Let's take a look. There's an issue here. We are using M100.1. So let's try again. Alright, now it should be normal. Let's check again. So this is a 1 second pulse. We've given the program and let it control the indicator light. At this point, the communication is established and it can be used normally.